Good afternoon. Let's settle a bit, finish your talks. You have a bit of time later too. Good afternoon, both to the audience here in Tallinn and also everyone tuning in online. I understand we have people around the world who are tuning in. Welcome to the AGEMERA Open Innovation Seminar, Exploring Tomorrow, Innovations in Mineral Tech and Beyond. I'm Kati Kongi, I'm your moderator today. So the mineral sector is undergoing a transformation and pressured by rising demand of critical minerals, stricter environmental standards, and the need to innovate faster than ever. During the next 2 hours, we will be discussing innovation in mineral exploration technologies and analyze the bigger ecosystem of critical raw materials for the future of innovation ahead. Critical raw materials have been gaining momentum for a while, and we have here the leading experts, technology developers, industry stakeholders, policymakers, and researchers modernizing it to make the realization of local supply happen while we are in the middle of increasing demand. So we now have a little pulse check. So take your phones, scan the code. I'm just moving away from here. And there is a question there. Please type the first buzzword that comes to mind when thinking of mineral tech. I'll give you just a little moment to do that. I believe that you have already had a lot of discussions today, so just one word, first thing that comes to mind. Let's see, are we done? All right, exploration, innovation, future. Which type of apple? Resource efficiency, SLE, cost. All right. While they're still coming on the screen here, there are many buzzwords today. Innovation, I think I've mentioned this word already, I don't know, 3-4 times in the intro. It is a buzzword: exploration, mining, resource efficiency. Complex. Thanks. All right. Thank you for that. And as we will be spending a couple of hours together, so let me introduce you to some household rules. So please post your questions via Slido. People who are here also, but if you want to raise your hand, we have that option as well. People here in Tallinn have also an option after we close with the presenters here and with our panel for a quick networking. It can be shorter, it can be longer. Let's see how it goes. Our agenda is really full today. So first half, we hear from the AGEMERA Project coordinator, Jari Otsenvaara. There will be a keynote speech by Gerardo Herrera from DG GROW, from European Commissions. We will get insights into the developed technologies with a snippet of direct feedback from industry partners too. So second half, we have an exciting panel discussion about the key driving factors of innovation and what the future holds for the mineral sector. All right, but I think I've spoken too long already. Let's kick off with the presenters. First to welcome is Jari Otsenvaara from University of Oulu, Finland. He is the project coordinator. He has to wear multiple hats. His research focuses on the post-mining reuse of mine sites and the possibility of already initiating the reuse process while the mine is still active. Jari will give an overview of the AGEMERA project, and hopefully the wider audience gets to know what actually AGEMERA stands for. He's also the founder of Muon Solutions. So, welcome. The floor is yours.
Thank you. It is a pleasure to be here. And AGEMERA is a Horizon Europe project, 7.5 million, 36 months, 20 partners, and from 11 countries. So that's a small summary. So my name is Jari Otsavara. I'm a co-founder of the Mion Solutions company, but I'm mainly working for the University of Oulu as a project researcher or project manager. But now let's dive into the project AGEMERA, the reason why we're here and why our deep tech companies are here as well, eager to come and present their stories. So briefly, Europe needs resources. Europe needs critical raw materials. And one of the Critical Raw Material Act's goals is to secure the supply from Europe or from friendly countries. And thus, we have been operating even before the Critical Raw Materials Act came to in place. So we have been operating in Finland, Germany, Poland, Spain, Bosnia-Herzegovina, Bulgaria, and also Zambia. Our work has concentrated on enhancing the knowledge of the geological systems throughout the study areas to understand where and these critical raw materials could be found, with what kind of formations they are associated with, and are they economically feasible at some states. Then we have had the deep tech development. We have 3 innovative technologies plus a unique visualization platform to drive with it. And then we have created new social scientific tools to help to understand the perception of the local communities towards mineral exploration and mining. We are not looking if you are pro or con. We are looking what are the things affecting your opinion regarding mineral exploration and mining. One of the key aspects has also been raising awareness of metals and minerals in our everyday lives, and that we have been producing through university courses, public workshops, dissemination events, and many more different kind of public activities. So we have 3 technologies. We have myography. Nowadays, the official term is Mion imaging. You will hear more about this briefly. Then we have ambient noise seismic surveys developed by our partner Lithica. The Mion imaging is developed by Mion Solutions. And then drone-based electromagnetic surveys developed by Radai. And what makes this project unique is that this project idea has been formed from the idea of our partner SME companies. So not that it's from up, down, but this is from down, up project. And this has actually been one of the criteria why our project was chosen as a Horizon Europe technological success story. Something about the SLO tool. We have tested this in multiple countries, and with the second round, we have been able to reach more than 1,000 replies from different countries. And we are looking at how the exploration companies, the mining companies are interacting with the local communities. We are looking at what are the economic structures of the communities affected by mineral exploration and mining, and how the companies are communicating with the local partners. Too many buttons. And then about the university courses. So we have launched 2 courses, one here at TalTech and the second one at UBUF regarding the European critical raw materials for the green and digital transition. These have been open courses, and you are able to find more information about the courses on our website, and also how to sign in for the courses and learn more about the topics. So thank you. I will now pass the floor to the next speaker.
Thank you, Jari, for that comprehensive overview and showing how AGEMERA really supports European CRM goals, so critical raw materials goals. Now next, joining us online is our keynote speaker, Gerardo Herrera, from the European Commission DG GROW. He'll speak about the future of critical raw materials and this industrial transition. In addition to his role at DG GROW, he's also a researcher at the Instituto Geológico y Minero de España. Hi, Gerardo. Do you hear us well?
Yeah, I hear you very well. Do you hear me as well?
Yes. All right.
Good.
The stage is yours.
Fantastic. Thank you so much for this invitation. I'm very pleased to join you all, even though in this format. And the reason why I'm joining you like this is because now I'm in Poland. We are in the high-level conference of raw materials that is being celebrated by the Polish presidency here. And yesterday we had a meeting that I think is relevant for you to know. We had the meeting of the Critical Raw Material Board subgroup on exploration, where the member states were presenting the draft ideas of the national exploration programs. And I want to say this because exploration is really the foundation stone, the most important part, I would say, the starting point of the Critical Raw Material Act. And this is what I'm going to present you now. If I can share my slides. I suppose that you can see the slides. So as I was saying, I'm not going to go through this, of course, why these critical raw materials are important. We all know these are necessary for our industry, for the green and digital transition, for defense and space needs. And we are living in a crunch, in a global crunch where we see supply risk possibilities because of the high concentration of some commodities in few countries that are driving the market crazy, and some geopolitical weaponization of these commodities that we consider critical or strategic in this Critical Raw Material Act. And this is why the Critical Raw Material Act was defining the list of the strategic raw materials and the critical raw materials driven by the supply risk, the economic importance, being the strategic raw materials a subset that is key for those strategic technologies that will drive the green, the digital, the defense and space industry for the EU. And together with this list of strategic raw materials, we have set the benchmarks 2030. These are the long-term, well, not so long-term, but short-term goals to achieve what is to improve our domestic capacities and to improve the diversification of supply of these strategic raw materials for the EU market. So the pillars of this Critical Raw Material Act are four. We want to promote the domestic capacities. We want to improve our capacity to monitor and mitigate the risks related to those supply disruptions that can arrive to the markets. We need to diversify to reduce our dependency from third countries to be less dependent. And we want, of course, to enhance the circularity and the sustainability. But all the conference where we are just now today, it's all about how to improve this industrial dimension in Europe, our domestic critical raw material value chains from exploration to extraction, processing, recycling. Here we have the list of the critical raw materials and the strategic raw materials in green bold. And as I was saying before, yesterday we had this meeting of the subgroup of exploration. The Critical Raw Materials Act is being implemented by the Critical Raw Material Board, that is the Commission together with member states. We have 6, let's say, subgroups, working groups in charge of the different parts of the implementation of the Act. And one of them is fully dedicated to exploration, to the national exploration programs. And this is something that we were discussing yesterday. What are the draft ideas of the different member states to implement, first to design and implement this national exploration program? And all of them were speaking about applying innovative technologies that can be useful to improve our capacity to identify the potential of the EU to detect critical raw material deposits. So very important, the innovative technologies, the projects like AGEMERA that are providing these technologies, possibly for the member states to well develop and implement these national exploration programs. But this is important not only for the national exploration programs, but also for the strategic projects. We have selected, as you might know, the first list of strategic projects in the EU. These are 47 projects that will be developed in Europe of strategic raw materials. These have been selected from a total amount of 170 applications. We have also some projects in third countries that will have to be still published, but the list of the EU projects is already there, is already out. And what I want to say is, of course, we want to improve our capacity to produce strategic raw materials in the EU, but this is what we have, these 47 selected projects in 13 member states of 14 strategic raw materials covered. And as you can see here, we are covering in the different countries extraction, processing, recycling, and substitution, the different parts of the value chain. But I say that it's important, the exploration technologies for strategic projects, because we need to create an industry around strategic raw materials that is still not strong enough. So we need a lot of junior exploration companies that can develop new projects, new strategic projects that can apply for the strategic project calls that will be coming. There will be a new call in June this year, that of course is going to be early for an exploration project, but for the years to come. So we need a base of junior exploration companies applying innovative technologies as those developed in AGEMERA to present applications for strategic projects in the EU and in non-EU third countries where these strategic projects for the EU can be developed. Here, for example, I show a graph where we can see the distribution of commodities of the selected strategic projects. We can see that most of them cover the battery raw materials, but are also copper, rare earth, and some other key commodities for space and defense. So what are we going to do next? Now we have this first list of 47 strategic projects, so we are going to identify what they need in terms of supporting them from the viewpoint of the financing, but also from the permitting. And this is why we started to do regular meetings with the project developers to well understand their needs. And then what we are going to do is to do pitching sessions, for example, with financiers. In the case they need finance, we want to help them to bring the public and private financing institutions around specific projects so they can find the best financing tool, solution, instruments for these projects to be developed. So this is the work that we are doing now. And together with this support of accessing the financing and, of course, accelerating the permitting, working together with member states, we are setting up an offtake mechanism, putting together the projects with possible demand, and we are developing a demand and aggregation matchmaking mechanism or joint purchasing platform that is going to be developed throughout this year with the idea of meeting demand with global possible providers of strategic and critical raw materials. So this is what we are doing. And as I was saying just before, now we are almost 1 year after the Critical Raw Materials Act entered into force. We had the meeting yesterday with the member states on the national exploration programs. By May this year, we will have the first final design of these national exploration programs, and then member states will have to implement these national exploration programs that we will be monitoring in the years to come. And this is the base that we believe is fundamental, a cornerstone for the EU industry, for a constellation of junior exploration companies to be developed in Europe, developing, applying, and innovating exploration technologies as they have been doing in this AGEMERA project. So this is my brief introduction. Thank you very much for the invitation, and thank you.
Thank you, Gerardo. And can you stay on for a moment for open questions? So I open the floor to some questions.
Of course.
And please post them in the system, or you can also raise your hand here on the floor. While people are thinking, I will ask one question, because I think the list of projects is very long, and the goal is very ambitious. So what do you think, what type of mindset shift must the sector adopt to thrive? So has that happened? Is there some sort of mindset that needs to happen? What's your take on that?
Well, we have the Critical Raw Material Act to change a little bit the paradigm. We need critical raw materials, strategic raw materials for our security, for our competitiveness, for our economic development, and to maintain our standard of living in Europe. So we have created this critical raw material with this concrete tool of the calls of strategic projects to stimulate that project developers believe that we can improve these hurdles that the industry had in the past on developing the projects. And the hurdles were those related to permitting, so we are streamlining the permitting process by this regulation. And the other important hurdle was the access to financing. Now we see how public and private financing institutions are seeing mining industry and mining projects in a more positive way. Recently, for example, EIB was announcing their action plan saying that they will invest in critical raw material projects. And this is a change of mindset because they will include extraction and processing projects. But as I was saying, this is very good for the projects that we have now in the pipeline, and also very good for the projects that will come in the next call. But if we want to keep on having extraction and processing projects in the future, we need exploration. This is why I was saying it's very important, these national exploration programs, because it's our investment for the years to come, thinking about projects for 10, 15, 20 years to come. So this is why we need to create this effort together with member states, and we hope that with this effort with member states, we are going to stimulate the creation of these junior exploration companies in the EU that can develop new projects in the future.
Thank you. And I think also now we have a couple of questions also from the audience. So how does the Clean Industry Act boost activities on raw materials sector? These are interconnected. So how can you comment kind of the boosting from the Clean Industry Act and getting this into the sector?
Well, at the end, the Critical Raw Material Act will be the answer, no? This is a focused solution from the Clean Industry Act to support the sector. So we are really focusing the sector through this Critical Raw Material Act and the whole implementation and how it connects to the rest of the industrial package that is being developed in the Commission.
Yeah, so it's a whole, let's say, whole big deal or kind of the whole package that you are developing.
Yes, where we have the specific component of the sector in the Critical Raw Material Act development, implementation.
Yeah, and what is the biggest challenge of implementing new technology in CRM exploration? What do you think kind of the biggest challenges to outline here?
It's a question that is difficult to answer by a policymaker, because at the end what we want to see is more exploration projects being developed in Europe, and we are very happy to support through Horizon Europe programs projects as AGEMERA that are developing these technologies. So we hope that this project will allow to put these tools available in the market for member states to develop the national exploration programs, and also for mining companies that can use them to improve their exploration strategies or campaigns. But I honestly don't know about the challenges. I think that from the innovation viewpoint, we are putting some funding possibilities through Horizon Europe programs. And then we hope that now that we have the industry developing the mining projects, there will be a need for these technologies to be applied if they are good enough to be used and improve the, let's say, the success ratio, because I know that is a very critical number, no? The success ratio in every exploration campaign, and this is what we want to improve, that the technologies are improving these ratios with the innovations that you are developing.
Yes.
I don't know if it makes sense, but
I guess we will see some of those solutions later today too, and get some insights how they tackle those challenges here. Maybe last question to you, Gerardo. So what are the agenda, what's kind of the agenda for these projects which were not selected on the first round? Are there some sort of supportive actions to those non-selected ones, or what's happening with those?
very good question. Well, let's say that we were selecting those that are closer to contributing to the 2030 benchmarks. So we have this clear goal in the Critical Raw Material Act that is contributing to the 2030 benchmarks by increasing our domestic capacities and potential in Europe. So those projects that are still in an early stage, that we see that maybe they can not contribute clearly to the 2030 benchmark, were maybe those that were not initially selected, but this means that, of course, they can apply in the calls to come, and that will very much depend in the state of development and maturity of each of the projects, because there is a call coming in June, and there will be more calls coming next year. So it's an open process. We are not going to ban a project that was, let's say, not selected, because we are not rejecting any project. It's simply that we are selecting those that are closer to help us meeting the benchmarks. So it's simply a process that could be restarted for these companies.
Yeah, so everyone has room for improvement. They can always come back and improve and maybe get selected with the next rounds. So
I'm sure that with these technologies, with these technologies developed by AGEMERA Project, they will improve the projects and everything will be fantastic. So yeah, of course.
It's a great motivation for everyone. All right. Thank you, Gerardo, for this great insight.
My pleasure. I wish you all the best for this meeting and success for the project and more importantly, for the development of exploration projects in the EU.
Thank you so much.
Bye.
All right. So let's pick up the pace with the innovation showcase. So let's talk about cutting-edge, non-invasive mineral exploration and data visualization solutions. We have here 4 technology developers who have about 10 minutes to catch everyone's attention, give insights. It's under the AGEMERA project. And talk about their core technology, what's been going on, latest, greatest. And they will also be followed or matched with an industry partner. So it seems like we have kind of like a live race or competition happening. Let's see how the developers do. Actually, I'm kidding. We hear about the insights, benefits, future potential. And first up, we have Ari Saartenoja, who is the CEO of Radai, and he will introduce their advanced electromagnetic and seismic survey tech. And here, floor is yours, Ari. They will run.
I guess, yeah. Okay, hello everyone. My name is Ari Saartenoja, founder of Radai company and also part of the AGEMERA project. We have been developing quite a long time this kind of system. Let's see if this video is working. Can you put the video running there? At least it's not. Yes. So this kind of setup, we have been developing about 8-9 years now. It has been flying only last 2 years, but we are developing the sensor system itself. It's an electromagnetic system, so it's measuring the electromagnetic field. We have a transmitter. It can be the transmitter in the ground or in the plane, and this is the receiver which is receiving the signals. And based on the conductivity of the ground, of the bedrock, it is changing our signals, and that's what we are reading in the receiver. And where this system is used, it is used for mineral exploration. Nowadays, this similar system can be used, or existing, this kind of electromagnetic systems has been used in the ground. So people are carrying the system in the ground. But now we have been trying to implement it into the drone. And then we need to a little bit innovate also, because the sensor system, it's extremely sensitive and it has to be quite far away from the motors and all the noises from the plane. So we need to buy a rope and then put the glider 30 meters behind the plane. And this is the one what we have been developing in AGEMERA. If there are any geophysicists in the group, it is a frequency-based frequency domain system. So it is receiving 3 different frequencies. There are also different kind of electromagnetic system, but this is a frequency-based system. And it is highly needed in the market. For our normal business, our company has been running now about 10 years, so we are doing magnetic field measurements, mag surveys, and it's also innovative, really good system, but I can see that customers are really much more interested about this electromagnetic. And what I can say that when we succeeded to finalize this, we are planning to do second our commercial pilot survey after 2 or 3 weeks in Finland. So we are really pushing this to the market. And the idea is that use also same time other geophysical methods. So we take the electromagnetism and then the magnetic field itself. So 2 different systems at the same time. Here is just little illustration that how does it look like. So it means that in the bedrock down there is some conductive, and that is changing our transmitted signal. That is the physics behind this. Challenge is that the change for the signal is extremely small. We are talking about femtoteslas. It's a physical term, but anyway, it's extremely small anomaly what we need to detect, and that's why we have been developing it quite long time. Yes, okay, this is mainly what I told earlier in the video. And then, of course, highly big part of the development is also the interpretation, how we process the data. We have been developing own tools for that, making the 3D inversion for the data. But anyway, point is that with this kind of setup, 3 frequencies, they are reading there. In future, of course, we can change the frequencies, but for the prototype, we need to select some frequencies what we are using. And in future, we are also planning to do not only mineral exploration, but also water detection. So but environmental surveys. We are interested to detect water. So that could be also another business possibility. This drone, it's just not too expensive, cheap foam plane, but in future it can be replaced a little bit bigger or much bigger depending on the market needs. But this is the concept what we have been developing now. In Rosen, actually in Rosen, in AGEMERA, we made the first surveys. We were testing the system, and here is the survey area. And now idea is that, can we see them? These are the flight lines, but I just would like to invite our customer, Irina, talk here. I was expecting his name already here, but anyway, this is the survey lines, what we did, how we did the survey area itself. It was 5.6 square kilometers, 50 meter line spacing, and that's the area what we flew. And these kind of pictures in the Rosen area itself. There's in the down right picture, there is Stoyan, also the person who was organizing the trip and helping us to make this survey in Assarel open pit area. But now I will ask our customer, Professor Irina.
Thank you. It was mentioned in the morning that we have to combine geophysical methods to have really complementary data and really not only geophysical but also geochemical and field data. We need to define the problems and have really good results at the end. So let me introduce you to the region, because now we are going to a copper porphyry belt in Europe, in Eastern Europe, which is part of the so-called late Cretaceous Apuseni-Banat Timok-Strednogorie belt. And it is formed during northward subduction on the European part and the closure of the Neo-Tethys. So generally, it is part of long Tethys belt, which we can follow from Bulgaria, Romania, Bulgaria to Turkey and Asia further. There are really world-class deposits in this part, mainly copper deposit, but actually the potential for byproducts, but other elements, critical raw materials, is not fully studied. The environment is compressional to mildly transpressional, but what is very typical for Rosen is that it is formed during an intra-rift stage in the magmatic arc, so it's an extensional part, short-lived. I really mentioned this, they are really world-class deposits, especially in Serbia, I would mention, and also just for the audience, that the oldest copper shafts in the world are found in this region in Serbia and Bulgaria. So just going to the region of Rosen, where the geophysics methods, the new methods were applied. We have multiple veins and dikes, typical plutonic volcanic complex. And in the past, more than 40 copper veins were mined to depths of 1,000 meters, but only for copper. And actually, many critical elements were wasted at that time. So the style of mineralization is recognized as IOCG, which is absolutely new for the region. And actually people who really know such type of deposits, they have the eyes to see this, like Silito visiting this part. And the typical mineral association and geochemical association is iron, copper, gold, moly, also light rare elements, usually with apatite, coming with lapatite. And so this is a special model of IOCG, this magma derived. But what is very important is that these findings opens new perspectives in terms of metallogenic potential for such deposits in the whole ABTS belt, because such magmatic complexes are also there in the western part, in Serbia and Romania for sure. So, and let's have the data. So, actually what we see, there are some positive anomalies and one negative, which obviously is connected to form mining there. And what is also well to see, you see in black the veins, and they correlate pretty well with the positive anomalies of the magnetic survey. So the magnetic results give good basis for reconsidering the geology and initiates new exploration activities, not only in Bulgaria, but generally in the whole region with copper porphyry deposits. And so maybe at the end, I can give you to make the conclusions. From your side, from our side, we see good potential.
Okay, these are just last pictures, 3D inversion of this earlier magnetic image, what you saw. And basically what we deliver a customer is this magnetic image, what was the previous slide, and then this kind of 3D inversion models. And based on this data, customers then can start planning the drilling program. Of course, they will use all kind of other data, but this would be one key component also to deciding where to drill and which direction to drill. Okay, thank you.
Thank you. Stay for questions as well, please. So please post the questions or raise your hand. And I think it's great to see how technology is already applied and the value created in Bulgaria, and you see the data here. So I'm just checking. We have, I will ask a question that, what is kind of next for your, what's next for Radai? What's on your product roadmap? What are the next, let's say, phases of your development for the product itself?
Next phases are that we will improve the system further so that it will be fully ready for commercial use. And it's really close. Now we are pushing to the market. After a few weeks, we will go to make the next step. And then idea is we have subsidiaries in Tanzania and Zambia. So idea is that when it's working, we do the surveys, expand it to Finland, Sweden, Norway, Scandinavia, and then to our partners in Africa. And of course, it's possible to expand other countries, but this is the first step. Through our partners, we would like to expand.
Mm-hmm. Yeah. And maybe to take the last question here also, that if you can comment maybe on the, what would be the technological innovation to detect the underground water? What's your take?
Yeah, I would say the innovation is that if our sensor is sensitive enough to see the water in the ground, because we are developing this kind of sling round system. It's flying transmitter, receiver, and flying large areas. So where I see an interesting business is that we could cover, like, let's say 50 square kilometers. And if the sensor is enough so that we can see some water veins, water areas, then it will be the innovation. According to our tests, it should be sensitive enough, but first of all, we focus on mineral exploration, and next one is then the water detection. But the innovation would be this drone-based system sensitive enough, and that would be really killer product if we could see the groundwater there.
Good to put it in your roadmap then.
Yeah, absolutely. It will come there. Yeah, sure.
All right. Thank you so much.
Thank you.
So let's move on to our next technology developer. So we have here Marko Holma, who is the CEO of Muon Solutions. I was just wondering, imagining X-ray vision, but for mountains, mines, and so on. So we learn a bit about the technology here, and after that, the evaluator for the technology will be Franjo Sumanovic, University from Zagreb. So floor is yours.
Hear me? Yes. Okay, it seems that we lost the right colors. Can we do anything about this? Possibly not. Okay, so welcome to hear about cosmic rays and cosmic ray muon imaging, which is also called myography. I will show you what we did in AGEMERA project. What is going on? Okay, so AGEMERA technology success story for the Jaice bauxite mine survey we did in Bosnia-Herzegovina. And this is our company's, not the whole team, part of the team. We are a deep tech company developed in Finland, starting 2016. I'm one of the co-founders, and I'm an economic geologist by background. And the methodology is called muon imaging. It's an advanced geophysics method using the secondary cosmic radiation coming from the sky due to the primary cosmic rays which come from the galaxy and hit the atmosphere. And in the process, they are generating these short-living, fast-moving particles called muons, which are interacting with the material by losing energy. Okay, so the method is completely passive. So it's observing the direction and counts of these muon particles coming from different angles, and they go through the rock and losing energy according to the density. And the more dense something is, the more energy the muons are losing in that material when passing through it, which means that wherever we are detecting the muons, we get different numbers of muons in different directions. Directional information of the density between the detector and the sky. And the muons go with straight trajectories, which means we can recalculate or model the density distribution in the volume of what we are observing. And you can do this with different methods, two-dimensionally or three-dimensionally or time sequentially, also called time-lapse density imaging. And in this project, or let's say success story, we used the muon tomography method, which means three-dimensional density distributions models of the volume measured in the Jaice bauxite mine. And here you can see the first visualization. The grayish data cloud there represents the volume of rocks where we got the data. So due to the reasons where the muons are coming from, there is kind of distribution about 70 degrees from the vertical to each direction where you can collect the data. That's why it looked like a little bit cone-like. And on the right-hand side, you can see three different sections. Two horizontal sections and one vertical section of the data. That's why it looks like a cone. And inside that volume, there is this higher density objects which is spatially corresponding to the drilled data of bauxite location. And for those of you who do not know what is bauxite, that's the primary source of aluminium and one of the critical raw materials needed in Europe and elsewhere. And so-called field of view is showcased there on the left-hand side, and the detectors are built in a way that you can tilt them in different directions. There are also different types of detectors by shape. This is so-called muon telescope. We also have borehole detectors for cases where you don't have tunnels. Naturally, in early stage or greenfield exploration, you usually don't have tunnels. You have to drill, baby, and then you can use these technologies these new novel technologies to reduce the number of unnecessary drill holes and improve your targeting, find better the target of your interest. And here is another visualization of the same data, showing now the three-dimensional model of the bauxite distribution in the host limestones. Okay, this is a little bit fast moving. So here you can see a contact between two horizons of limestone. One that is host in its upper surface, it's host in the bauxite. And as you can see, the density data built from muons is showing that the upper face or upper front of the bauxite is rather smooth and very sharp comparing to the above lying slightly younger limestone. And the lower surface is irregular, which fits perfectly the lithological model of how these bauxites have been formed between these two limestones. So first there was a shallow sea formation of limestones, then uplift, and then in tropical environment, so-called bauxitization processes where the aluminium was enriched in the karst environment. That's why the lower surface is such irregular one. And then came another event of sedimentation over that. And if you are watching this or studying this, you can see not only the lithological contacts between two units of limestones, but also the shape and distribution of voxels of density, three-dimensional pixels of density. And that's the photo of original, the real contact between these two rocks. And the blue line here is showing the underground tunnel or adit where we installed the muon telescope and had 5 points to make this data. And then my conclusions are that we successfully imaged this period bauxite lens between two limestone horizons. So these bauxites are not in the outcrop, they are in the stratigraphy, and they are pretty difficult to pinpoint by using conventional or other geophysics in general, because they are not magnetic, they are not conductive, and there is not big density contrast between these bauxites and the country rocks. So the density difference is 0.2 to 0.4 or something like this. But in our data, you can see that this worked just fine. And as something to take home, I would say that our technology offers mining companies a non-invasive, high-resolution tool to de-risk exploration and reduced drilling costs. Although maybe if you find a lot of good stuff, you actually increase your drilling cost, but at least you are using this for getting the sweet spots, what you are actually wanting. So that's from my side. Now maybe Professor Franjo Cumanovac would have a comment.
Thank you. I would like just say a few words in the name of the Rudnici Boksita Jajce, bauxite mines of Jajce, and University of Zagreb, Faculty of Mining, Geology and Petroleum Engineering. Actually, we together choose these sites due to the fact that bauxite deposits are placed in very, very complex geological models. They are appearing in the depressions of the bedrock, which are always limestones. In our case, it was Cretaceous limestone, but could be also Paleogen limestones. And bauxite deposits are very irregular in shape, in size. Very different sizes can appear because of, we can imagine them as a pocket in the limestone background. Also, we can expect very complex, very rough conditions, surface conditions with bushes. We can expect also high level of noises, geological and urban from environmental noises, and it could decrease also resolution of the applied methods. I can say that I see actually that myography as a new technology can provide for better constraints, as Mark already told, that can can provide for more efficient exploration, for decreasing of the costs of the exploration. And of course, to decrease overall costs of exploration. And especially together with other geophysical methods, I see that electrical tomography can contribute a lot in this case, and combination of ground geophysical methods and myography can decrease the limits of the so-called main problem in geophysical and geological interpretation, ambiguity of the interpretation, which means that no one method can provide for a unique solution of the problem. Thank you.
Thank you. Thank you, Professor. I will ask from Marko, what do you think, what are the limitations for muon technology and kind of the developments that you have in your pipeline, something you can tackle already, you see for looking forward in your product roadmap? Maybe you can comment on that, what's ahead.
So every method has its shortcomings. In muon imaging or myography, it is that we have to go below or side by of the target of volume. So we are not generating the muons, therefore we cannot directly observe something that is below the detector, which means that if you have a mountainous area or hills high enough or deep enough, we can go to the valleys, put the detector there, and then see those muons going through that volume of rocks in the hill, and then see where are the drilling targets, or let's say faults or shear zones inside that. If the country is relatively flat, then we have to go below, which we can do by two different methods, by going through, using drill holes or going through tunnels. And another shortcoming, method-related shortcoming, is that we cannot generate the muons as set, so we are stuck with the muons the sky is giving us, which means that to build the statistics that we can reconstruct the image, we have to measure relatively long. So this is not something we do normally within a days. We can do it within a days, and sometimes if it's only about drilling and finding the drilling targets, not image are necessarily even needed. But if we want to have a 3D model, then it usually means several weeks to months measuring time, depending on the depth. The deeper we go, the more times it takes. And regarding the other question, we are currently scaling up production of detectors and finding new customers, and also improving the R&D and software and AI and machine learning and all that normal stuff.
All right, thank you so much. Busy, sounds like. Thank you. In our panel, we also have one other muon technology developer here, so we hear from their side as well, an angle. Next up, we talk a bit about the collected data and how it can be visualized, how it all comes together. So OptNet is developing the graphical user interface using AI, and they have also actually described how they have decades of hardcore critical industry experience. So maybe Barbara Stimac-Tumara is here to untangle this statement as well, but also talk about the platform. And afterwards, we have also Marko Paavola from VTT online, who can reflect on the usage as well. So thank you.
Thank you. Okay, so I will just let the video go in the background and move a bit to the side so everybody can see properly, but I will talk about over the video. So once again, hello, my name is Barbara. I'm here representing OptNet. So to kind of switch from the two non-invasive geophysical methods that you were presented, this is something about different. And before I give back to other geophysical method, what we do is the data visualization, and that is done through monitored AI. So that is a core product of OptNet, and the spin-off of the product was AGEMERA Web UI, or that you see here currently me playing with. And what it is, so it's a high-performance, high-computing geospatial platform, so that composes of two main parts. So it's a backend that is responsible for processing and visualizing and automating data flows using something that we have named AI Knowledge Pack. So they are self-contained, automated Python-linked software packages. But what I want to put an emphasis here is the web UI part that you have seen now. So it's a comprehensive solution for geospatial data monitoring. What you can think of it is a web-based data repository of published data set coming from the back end to the front end, and it can be visualized as you see. So at this point, I think I have already went through some data, but this is, for example, MUON data, Radai data that has been presented before and with all of its functionalities. What I would like to also mention is that the platform has a full 2D and 3D capabilities. It is powered with the AGEMERA AI assistant that you can see on the bottom left corner, which understands your natural language queries, and you can ask it for the location of the published data. It comes with all the attached metadata, and of course the data can be visualized. So at this point I'm showing a bit of data coming from our partners from KGHM or Kuprumin data. That is a bit of a misspelling in the title, but let's ignore it. That is an example of the numerical model that was developed by them. So what I would like to also mention that the platform is, because of its nature that it was built, so the data here is only used for visualization and it is not downloadable, so you do not have access to the original data set. It can only be used for the visualization. If it's necessary for download, that's a different possibility. Also, the data is protected because the platform at this point is invitation only, email invitation only. And that's how it can be accessed, but also the inside of the invitation only, the data can be diversified into groups, so you can have certain partners, if they have proprietary data, who do not want to have it visualized for the other somebody else. It can be also protected like this. At this point, this is the 3D data, so the MUON data that you have heard about. So this is how the data from the area of Jaice has been visualized in the platform. And you can see that it would end up being quite similar or the same as it was in the images that were presented in the previous presentation. And with this, you have to apologize for my poor flying abilities. I never played enough PlayStation, so I do not fly properly. But that is more of a that is not a platform problem. But with that, also, other than the project data that was visualized during the project, the platform is also capable of performing geospatial analysis based on Earth observation data, satellite mostly, but it can work with both open source and proprietary data, and it is completely multi-source, capable of fusions of multi-source data. Also, these are some informations that can be found. And actually, with this, I can let you continue looking at the video and everything that is possible, but I think it would be a quite good idea to give the floor to my colleague who is supposed to be online. And is.
Hello?
Yes, we hear you.
Okay. So hello everybody. And my slides are visible, I guess, or not?
Not yet.
Yes, so my name is Marko Paavola. I'm the principal scientist in the optical measurements team in VTT Technical Research Center of Finland. And I have had an honor and still have an honor to coordinate couple of big European Union projects related to the mining industry in which we are using the platform. And in these projects, the motivation pretty much has been the green transition, of course, and the public acceptance of the mining industry. And in total, these projects are nearly 17 or over 70 million euros. And there are lots of European partners involved in these projects. And we have lots of different applications being developed at the moment and previously. So there are lots of different AI knowledge packages, so tools for the mining industry that can be used. And the areas where we work include exploration, operations and safety, environment and prospecting and exploitation. And the platform has also been integrated to various tools and will be integrated to various tools developed by the geological surveys, for example, Geological Survey of Finland. And also this morning I have heard that the integration has been successful with also Flag 3D tools. So things are really progressing well with the platform development, and it's a great honor for me to be included this development. And in our current project, we have also mining sites involved. So we are extracting the requirements from the mining industry and directly developing different applications based on the actual needs of the mines. And I must say that there has been very much interest, for example, public acceptance domain. So people are interested in visualizing and showing the effects of the impacts of the mining operations on the environment and be really transparent towards the communities around the sites. And as a conclusion of maybe both from this project is that I think that this kind of artificial intelligence platform with Earth observation is a really, really helpful tool for the mining industry. And we have already seen reduction of person months and environmental impact of exploration, for example, in GoldenEye project, safety improvements, planning and reporting, time reduction, environmental safety positive impacts there, and lots of possibilities to develop tools for the, for example, officials. Of course, this kind of multidisciplinary platform requires a lot of work from the researcher's point of view. So I think a joint effort is really needed in order to bring together the industry, the academic partners and the ICT competence. But I think the fruits are very, very good here. So we can achieve a lot in this platform. And of course, we must take into account that nowadays it is very important that we have the security of supply and we are independent when it comes to the critical raw materials to the degree that is possible. So for this we need the public acceptance, and I see that the platform is very good tool for here too for improving the public acceptance. So thanks a lot. That was my short presentation. Maybe I will quickly show the current team that I'm working with. So as you can see, there are lots of activities ongoing across the Europe at the moment. And then there is also the web page and newsletter if you're interested in the Golden Dam project. Thanks a lot from my part, and I hand it back to the Tallinn.
Thank you.
Thank you. Again, feel free to post some questions. At the same time, I asked from an angle, what is your take? So data was before, now we have AI, has been for a while now. How about decision making? How has decision making changed for exploration teams, for example? How has AI changed that? Do you have kind of like a comment?
So what I would like to say from the point of view of the platform, what we aim to do with the platform is if you provide a lot of information for the people who are doing the decision-making, having a large amount of data in one place that could overlap one another and come from multiple sources, it can lead to a much secure decision-making. And the role of the AI here is completely traceable. So everything from the development point of view, from the metadata, everything is very traceable, so there is no possibility of AI inflicting the data decision, since the data decision is still being done by the professionals.
Do you also see maybe if you look to the future and think of different scenarios, because you have so much data sets that there can be more bold decisions, or kind of because there's so much more data? I mean, it's kind of...
Well, that is...
It leads to that anyways, right?
It would logically lead to that.
Yeah, all right. And we have also a question from the audience. So is the OpNet platform linked to the National Geological Survey databases in Europe?
No, it is currently not, but that is something that we would definitely consider as possible next steps.
All right. Then thanks a lot again, and we move to the next. All right. So thank you also to Marko. I think here it froze. So next up we have there should be something happening with the... Yes. All right. Here we go. So next up we have Martin Schimmel, who is from the Geosciences Barcelona. So the floor is yours.
Thank you very much. Good afternoon. My name is Martin Schimmel from Geosciences Barcelona, CSIC, and I'm going now to give the first part of this presentation. I'm basically speaking about passive seismic noise, which we are using in the AGEMERA project. Okay, so in the top panel, you do see a record of, okay, my mouse is not seen this. You see a record of 2 days of seismic data, a registration of a duration of 2 days. We have over here, maybe I'm pointing it wrongly, you see over here the earthquake, and everything before is seismic noise. So as a seismologist, traditionally, we have been using only records from seismic earthquakes, and so we basically use signals which we find within the seismic record to constrain the interior of the Earth's structure. Or anything else, the seismic noise, we discarded, we threw it away. Active data, active seismics refers to seismic where we have an active source. The wave field, the seismic wave field, is being generated by an active source like an explosion or a vibro, and we use this data in order to image or to constrain the interior structure. Seismic noise, waves generated by seismic noise are traveling through the same structure. And seismic noise is cheap, it is free, it exists everywhere, it is ubiquitous in time and in space. So everywhere, at any time, we have seismic noise. And only in the last 1-2 decades, day by day, we learned how to convert the seismic noise into usable data. And in this project, AGEMERA, we're using the seismic noise. Seismic noise is being generated by the human, by any mass in movements, by industry, but the strongest noise is generated by natural phenomena, like the ocean swells. The strongest noise on Earth are ocean swells in the middle of the ocean, which propagate into opposite direction by the same frequency, or storms, or rain. So what we do is we record the seismic noise continuously, a couple of hours, a couple of days, a couple of weeks or months. It depends on the problem at hand. And we developed our own methods to convert the seismic noise into usable data. Here you see an example. These are all cases from our work, from our group. And then we use this data to convert, to constrain the interior of the Earth's structure. So the interior of the Earth, sorry, or to monitor structural variability and doing tomography and so on and so on. It depends on the problem at hand. So the seismic noise wave field is very complicated. It's not possible to extract ballistic waves easily, to find reflections. So we have our mathematical tools or coming from physics like interferometry. So what we do is we construct a seismogram at one of the sensors here, as if the other sensor would be a seismic source. We call it therefore virtual source. And with this seismogram, with this constructed seismogram, we can constrain the structure in between the sensors. If the two sensors are at the same place, we basically determine what we call stereo offset reflection response. So we obtain the reflectors underneath the seismic sensor. So in the AGEMERA project, we basically used 4 methods. The first method I just explained, it is a zero offset reflection response. You do see here, for instance, an example. We image the depth of a discontinuity. In this case, the basement of the Ebro Basin in Spain. It is shown in colors here. The depth indicates the colors. We also use ellipticity inversions. In the noise, we have a lot of different types of waves, and we extract the surface waves. And the surface waves, Rayleigh waves, they have an elliptical particle motion. We measure this elliptical particle motion as function of frequency. And this elliptical particle motion as function of frequency is constrained by the structure underneath the sensor. And so when we speak of ellipticity inversion, it means that we find the seismic model which best explains the measured ellipticity as function of frequency. So, and if we have several seismic sensors and we do this, we can also get sort of tomographic images. We use also in this AGEMERA project, we also used other methods, but there's no time now to explain them. I just mentioned we use the ambient noise tomography and also the H/V spectral ratio inversions. I'm handing now over to the next speaker.
Hello, is this working? Okay. Thank you, Martin. So I'm Giulio Cassini. I'm a structural geology consultant and CEO and co-founder of Litica, which is a small consulting company based in Spain. What we have done in the AGEMERA project was applying this methodology, passive seismic methodology, in a data-rich case studies, which is located in the Iberian Pyrite Belt in the southern part of Spain. And the place is called Mina Concepcion. The Mina Concepcion was exploiting up to the 80s in an open pit mine, VMS deposits that are embedded in upper Devonian, lower Carboniferous volcanic clastic and volcanic rocks. And the area is characterized by, oops, sorry. There we go. So the area is characterized by very steep lithological contact, dipping 60 to 70 degrees to the north, which normally generates some challenge for seismic imaging. And the maximum depth to which this deposit had been located through exploration drilling is about 700 meters. In the area, there are 150 exploration boreholes, so this represents a very good place to test and benchmark how this methodology can perform in this type of scenario. So what we did 4 different deployment of stations arrays. We used 3-component seismic sensor of 2 and 4.5 Earths. There are 3-component sensors, and the duration of each individual campaign deployment was about 4 to 6 weeks. And in total, we deployed 114 stations. So here you see in this area here, in these geological maps, you see the black dots are the boreholes, and the white dots are the seismic stations that have been deployed. So these are very easy instrument to be deployed. They can be deployed a little bit everywhere in a very inaccessible area too. They only consist of a battery and the sensor and the data logger, and they can be easily dug into the ground. So at the end, during the acquisition, you see nothing from the surface. So next, this is just a couple of slides to show you a little bit the main results that we achieved during the AGEMERA project. Here you see the inversion of the ellipticity in this graph here in the middle, where you see all these colors. These are basically a tomographic vision of, is a 2D tomography of the geology across this section here that crossed the system. And we can clearly see that the ellipticity inversion was able to pick the main lithological contact. So we see the granite up here with the slow velocity. We see the andesite with the very high velocity here. We see the contact with the argillites here below. So this represents this cross-section, but in geophysical terms. So it was successful to image the subsurface, although the resolution wasn't enough to detect exactly the sulfide bodies because too small. This is another method, the autocorrelation. And here as well, we can see this is a different method. It's based again on a single station data. And we start seeing here some reflectors that correspond to lithological contact that are found, in this case, not beneath the seismic station, but they are found perpendicular to the inherent bedding or lithological contacts that are in the area. We did also some seismic modeling to benchmark and further develop and further calibrate the methods. And this is, we call it a digital twin technology. So we built a geological model and convert that into seismic, synthetic seismic data. And so we use that method to really further calibrate our processing method. So I want to leave you with this final slide on the conclusion, but mostly I would like to highlight the potential of these methodologies. Basically, these methodologies, they are really very cost effective, especially when compared to active source seismic. In fact, we can acquire and process the data at a fraction of the cost of normal seismic method. Of course, the resolution is lower, but they can be used especially in the early phase of exploration. And another advantage of these methods is that they have very low social and environmental impact. In fact, you saw that the installation is very easy and get unnoticed. Instead of, compared to the active seismic where you need explosive or you need to go in with very heavy and very big tracks, which can raise some concern across the population. So this could guarantee a social license to explore, especially in the early phase. And another advantage of this is that we can go anywhere. Like with the explosive or with the tracks, you are limited to places where you can access with these big vehicles. Instead, with this method, we can deploy it easily and quickly over almost any terrain. So I just leave it with that, and I will call now stage our customer testimonial from Sunfire Mazza, who are doing exploration in the Mina Concepcion area at the moment.
Hi, everyone. Okay, we work for Sunfire Mazza in the very Pigiti belt. It's a highly metallogenic zone, very known by, I think, everyone. One of the things that, or one of the challenges that we have in exploration in the very Pigiti belt is the find ore bodies deeper than 350 meters. The electromagnetics and gravity in this context helps, but there is a limitation there. We need to improve the geophysics and the method to find ore bodies. And this is where AGEMERA Project came into developing new technologies like passive seismic that we are seeing, that Martin and Julio are developing. this method, we hope that it helps us to see deeper. Since more than 10 years ago, there is no discoveries in Iberian-Pretty Belt, big discoveries from Magdalena. And we know that there is a big deposit under covers, but we need to see deeper. So it's very useful. I think the application in the future is going to be very good. So we are happy with that. Okay.
Okay, so little more to say. Thank you, Julio and Martin, for this great work. I think that in the past there is almost nothing about the passive SIGMIT in the exploration industry, at least in the Iberian-Pretty Belt. And seeing your works in this 3D theoretical model, comparing with the geological model with the boreholes, is amazing the correlation at how much the theoretical model and the real model. I think that if in the future we use more case of studies or apply this method, I think that in the future the passive SIGMIT will be a big position in the exploration industry. So thank you and continue working. Amazing. Thank you.
Thank you. Thank you also, Ritika. I will ask a last question, I think, because you mentioned sky's the limit, basically, and what next. So can you give a snippet into what is Lithica in 2035, how it looks like?
Oh. That's long time. Well, no. I mean, future development of this methodology, of course, we're just starting applying this type of methodology in the mining industry. Ambient noise tomography has been already deployed and is used commercially, but not these single station methods. So we're trying to really catch up and develop further these methods so that they can really be commercialized soon. So we need to improve a little bit the processing and the processing workflow to make it smooth and to make it kind of more, not automatic, but faster and better, yeah.
Yeah, makes sense, step by step.
Yeah.
All right, thank you.
Thank you.
So this was actually the last technology developer in the race. I don't know, was it a race? So I think, I mean, I'm joking with the race, but actually for the mineral sector, it's mineral sector is winning. So I mean, that's the important work everyone is doing, and also under the AGEMERA project. So now we wrapped up. I think after we are following with the panel discussion, everyone can have a networking moment with all the different technology developers later here. We are going into our exciting panel. So I think as we are moving our chairs a bit, and we're inviting the panelists, in the meantime, I have a little side note, just that we're not just sitting around. So we are tuning in from the capital of Estonia, so maybe a little fun fact about Estonia's raw materials. It's the only country that has mined oil shale on a large commercial scale. So thanks to this, Estonia has actually expertise extracting valuable elements from unconventional resources. And this is helping researchers to explore the recovery of critical materials, such as rare earth elements, from oil shale ash and mining waste. So Estonia may not have massive metal mines today, but it is turning its ashes into assets. But then, please, the panelists, come on the stage, and I'm happy to introduce you step by step. So we'll take a moment. So we can find our seats. So first, let's find our seats, and then we can, as you see here, so Jari, have Ari, Doris, Hannes, and myself. Yeah, and Doris is here, Hannes. All right, so as we're sitting here, finding our places, and we are going to talk about what the future will hold. And we have a lot to untangle. We're addressing the key drivers of innovation in the mineral sector, future of sustainable resource management, and the opportunities and challenges facing the industry. Sounds like a lot. So happy to give a little introduction. So we have here Hannes Plinte, who is the CEO of G-Scan. Then
Not CEO, founder.
Founder of G-Scan. Then we have Doris Põld, who is the CEO of the Estonian Association of Information Technology and Telecommunications. Then we already saw two of you on the stage. So we have Ari Saartenoja, CEO and founder of Radai Oy. And we have Jari Joutsenvaara, AGEMERA Project Coordinator, co-founder, and many hats, as we say. But first, let's warm up, and I will start with Hannes. So when you get up in the morning, where do you go? What do you do?
Well, I have also many hats, but my main activity is linked with G-Scan, which I was co-founded approximately 7 years ago. So the Muon tomography company.
Mm-hmm. All right. Doris, let's say line by line.
Okay. Yeah. So my everyday life is in the technology sector. So we're gathering all the digital technology companies in Estonia and representing their interest, boosting their collaboration, especially with other industries, and supporting their export.
So the question was that what I'm doing in the morning.
Well, where are you going, actually, kind of, you know? Where are you heading? What's your kind of goal for the day, you know?
What the heck?
It's a good interpretation.
So where we are heading, developing new innovations and just trying to expand the products, what we are currently doing, and that's the one what we are pushing. And going to other countries, that's where we are heading now.
Mm-hmm. All right.
Well, I would actually jump on the point, what I do first in the morning, that's switch on the coffee machine. That is the most important part. But otherwise, I think it's trying to make the world a bit better place, one step, one idea at a time.
Mm-hmm. All right. I will also say, because yes, I'm the moderator, but I daily actually work for the Estonian Innovation and Business Agency, so for the applied research program, and focus on the critical raw materials sector. So sounds like a boring answer, but I do also live for coffee for a while, and then I'll get going with different companies to advise and discussions going. All right, so first of all, we saw the buzzword, we had innovation, so let's untangle that a bit. So what do you see as the most impactful innovation currently shaping the mineral sector? I mean, AI, automation, geospatial data, we saw all sorts of things, but kind of your take on it. Maybe we start from that side right now, so Jari.
Well, I can't really say a single innovation, but what I really love in the current research and the current appliances is that looking at the former wastes as a resource. So I think this is one of the most important parts. So how to recycle, how to utilize the extracted materials better so that we would make less waste, and how to find new use even for the waste, that it would not be a waste, but it would be someone else's resource.
But do you have maybe some sort of a, let's say, a method or a technology in mind? Because, I mean, there's a lot that's happening out there. So, we saw like pyrolysis, we saw, if you want to point out any type of technology which is kind of making the waves.
Well, From the technological side, I would say these kind of socially acceptable technologies to be applied. For example, the technologies we have in our project. Then also the utilization of artificial intelligence or machine learning to find possibilities, potential in underexplored areas.
All right. Ari, you want to add to that, maybe? Or what's your take?
Yeah.
Impact?
No, nothing more to add. Maybe how I see that my company is mainly developing one kind of innovation, but what I see that in mineral exploration, we definitely need several different innovations, several different data sets which what we should combine together. So even just like we saw this presentation about the innovations, muon or seismic or radar EM system, it doesn't help only that system. We need together parallel different systems. Just like in AGEMERA we tried it, but it could be done even better, that how we combine different systems and develop tools for that. Because I would say in geophysics or exploration, 1 + 1 is more than 2. So it means that if you have one method and then you have another method, they are better than 2. Mm-hmm. So that's how I see.
All right. Maybe then we can move to Hannes, who can talk a bit about the G-scan technology and innovation there.
Well, we are relatively young when we are talking about the mining sector. So, but we are moving into the sector as well. So this month actually we will put our detectors on the ground first in our history. So it's coming. Talking about innovation, I would say that that AI and machine learning and such advancements are making the industry faster, moving faster. So basically, everything becomes accessible and doable in more quicker way.
Mm-hmm. But then to add to that, maybe Doris, you want to take it from your, let's say, a bird's eye view from the ICT side. That what's your take on the current innovative landscape and how you see the Estonian, let's say, companies doing and how they're tying into that?
Okay, yeah, good forming of the question, because I feel a little bit outplaced that I don't know very much about mining, sorry, but more like the technology side. But I think what is this kind of like essential thing for us when we speak in the technology sector is that technology itself is nothing. It's always together with other industry. The main value, the main innovation comes together with other industry. And this is, I think, something which is this kind of thing what has changed during the past years. That in the beginning, everybody liked to think about startup and it's always the digital company and always like in the IT sector. And so now more and more this kind of integrated ideas coming and the real innovation together with the AI and it's the real effects coming from other sectors. And that's where I think the technology goes and where it helps the most, what we can see. And when you ask about like Estonia and how it is, then of course, when you say Estonia, everybody, now it sounds a little bit bragging and always saying, oh, well, you always have, oh, you're fully digital, it's so nice in your place. And so, yes, it is digital society, digital government. I think it's like a difference there that we have. We are good in cybersecurity. We have very good startup ecosystem. But we have much to do when we speak about digitalization of other industries. And there, I think, something where we can generate the new value and where we have to look and have our approach.
But then maybe I relay this kind of bridge the question to Jari, that we talk about digital transformation, let's say in big different sectors, but if we talk about the transformation now in mineral sector and how it's, in your point of view, changing the operations and decision making in your experience. So can you bring some sort of, it's the digital transformation, there's a lot that has been happening for many years, but can you bring out any type of decision making that has changed in your life or like the operations in the past years specifically?
Well, if we look at the mining industry in general, it is really a century old in the technological point of view. But adapting the new sensor technologies, getting the data and process it, having the data accessible. So basically, looking at the process data at different stages with the rapid increase in the data amounts and also accuracy, you can fine-tune your processes and thus get perhaps a better profit for your end product. So I think the IT, the digitalization is helping the industries to become more efficient.
Are you want to add to that?
Yeah, I fully agree. I'm just talking about my own background, that how we have been developing in radar the systems, that we have flying platform, it's connected to the internet. In future, we would like to get the data real time. And then we have some subsidiaries in different countries. We would like to monitor them also real time. So we could have this kind of fleet control, and fleet means that flying, or it can be something else. But if we talk about drones, measuring data in different countries, different areas, real time monitoring, and then just like I told earlier about this mixing sensor technologies together. So if we have more and more sensors, what we are trying to build now, we are flying and adding more sensors same time. So this is digitalization, and this affects to the decision, like you asked, that what are the decisions what we can make when you get more data, more real time in the global scale. Because global scale, internet is everywhere. So basically the drone is flying. If you have a mobile connection, it's just a normal computer there. So it's not an innovation, but we just use it. But that's how I see that you can scale up and be more aware of what is happening different places same time, getting data real time, and that's where we are trying.
Makes it quicker.
Yeah, make it quicker, and then you might also innovate something new. When you get the real time data, then you maybe figure out that, hey, maybe we need this kind of survey method, because during the survey we found out that, hey, here is something. Maybe we should now move change something. The traditional way is that you do the survey and you do it, and then you process the data and see after 1 month or 2 months that what was the result. But this real-time processing could also change how do you do the survey.
Yeah. So one point is the digital transformation, but also we talked here about the kind of adjacent industries or some sort of technologies that can be applied in different sectors. What is your take on, let's say, I was giving kind of a presentation on that defense industry, and the current situation is kind of like, even though it's a dark topic, it has boosted the innovation landscape. So it has, because it's so critical to actually have those innovations quickly and applied immediately. So what do you see, what can be taken from the defense industry into the mining industry, and let's say vice versa, because let's say autonomous vehicles going into the mines which are not safe. Do you have any opinion on that? Maybe Jari can have a comment on this.
Well, using the fleets of drones, using different sensor technologies, trying to identify targets, it's basically a dual use case. using autonomous systems to map the environment, again, a dual use case. So from the mining industry point of view, I would say that as there will be less and less people working, but more machines working, doing the actual work in underground mines. In what time scale is a good question, but I would say that the automation, autonomous vehicles, the sensing of the environment where they are, or this kind of environmental and positional awareness, I think these are going to be also key aspects in industry, not only in mining, but I would say also in process industry as well.
Mm-hmm. All right. Is GScan also active in dual use?
Yes, we have some dual use applications, but if I'm asking the question, if I'm answering the question, what is a takeaway from defense sector? Then definitely I would say the speed of adoption and speed of innovation. So everything should learn from that. So that basically innovative ideas, how quick nowadays they turn into reality in defense sector. So this is the.
Do you want to add to that?
I just think that if I may ask, then one or two approaches to the dual use, it is today very important, and everybody innovation. Money or innovation follows the money, and that's why the defense and in many cases you see how the technology is trying to at least have this dual use and defense topic there also in order to get the fundings and so on. But one thing also what to learn, I think, from the defense sector is also speed. I very much agree with that part, but also the cybersecurity. I think the other sectors doesn't think about it enough. The security of their data, more technology you're using, then I'm as a technology, from the technology side, I have to say honestly also out that using more technology means also that they having more doors open, possibly, what can be, where to attack. So, and this is something where defense sector doesn't do any kind of wrong twists, and this is definitely also where to learn them.
Mm-hmm. Yeah, we talked about the speed, and so maybe Hannes, you can share the story of GScan, how it has been as a startup, how the path has been from initial to how it all went until today.
Well,
and a bit of the technology as well, if you.
Then I would turn to the first question. So what is not allowing to sleep during night? So actually it's doing deep tech companies just running against the time. So when we reach the target or the customer or technology ready, and then go to market, or shall the money will be over before. So it has been always been like running against time. So GScan has been developing. First of all, our idea was to build muon tomography devices for customer security purposes, but 2 years ago we changed actually our main focus, and now we are in built world. And since the built world applications are partly same or similar like some mining applications, then now today or this year we are also looking into mining sector. So. But everything comes from let's say real need. Everything. So we did, for example, we did nuclear reactors measurement of Paldiski abandoned Soviet nuclear submarines. Then we realized that actually we can see 10 meters into concrete. So that's definitely something very valuable which can be used in built world, and so that's how we turned into civil engineering sector, and
it's coming organically.
Innovation is coming from real needs. Yes.
What is and actually then going to Radai, because also as a small medium enterprise, what do you think is the role today's landscape compared to large players and so on? I mean, Giscan is also a small player. We have all sorts of developers. What do you think? What is the role that SME plays in this landscape?
No, so a road for the landscape. For the market landscape, or
for the mineral
mineral
sector, and also if you compare to the big players, so how those the small guys
how we can go to the market, or how we can
the role itself, basically.
Role itself, yes.
Yeah.
I don't know. Yeah.
First, diversification maybe, or kind of that. Big players are playing it more safe, but have larger pockets.
Yeah, absolutely.
Take on the small guys.
Or actually, big mining companies have big pockets, but they are not taking risk. They are using junior companies, which are doing actually the exploration. So this system is this kind of twisted that big players does not need to take the risk so much. So they are just using junior companies which are doing the exploration, and then if they find something, then big players might buy. But okay, if I'm talking about my company, it's much lower than these junior companies, because we are small service providers for these junior companies, and that is. But anyway, it's small players are needed, of course. And in mining industry, how I see, when I came to the market, it was really tough and difficult, because it's quite a old-fashioned, or how do you say, they don't take so innovative, so quickly new innovations. So they are conservative is the word, what I would say. And that's how it's also tough for new players come to the market, at least in mining industry. And you really need to show several times your data. Even you show your references, they don't easily believe. You need to show it again and again. But anyway, I see that service providers more like Giscan, and then Muon, Lithica, we are service providers which customers, junior companies needs also. So it's a mutual benefit, but and I would say there's some competition, but how I see that it's not in IT sector, I would say it's much bigger market. I would say there are talking about billions and billions, so it's quite much smaller, how I see. There are not so much players in this game, but even the money is not shared so much.
Yeah, maybe then Doris can give a hint on how does your association help the small players? I mean, now we talk for the ICT sector, but in general, so kind of like the support system that you have built through the association that you have.
Okay. Yeah, for technology companies, we have built this kind of clusters. We have a smart mobility cluster, cybersecurity cluster, and then IT cluster, more like concentrated into e-governance solutions. And with those clusters, we're doing the supporting export activities, doing projects together internationally with other similar clusters, supporting joint marketing, access to the market, so trying to do everything what's possible to lower the first level cost for the SMEs, that to meet with possible clients or get the contacts, and especially it's useful when we speak about when the client is public sector, for example, because in many cases public sector officials, they doesn't want to speak with one SME, but they are ready to speak at least in the first hand with a cluster. That's like neutral organization together with the companies, and then we can go on from there, for example, and for one SME to be in one, I don't know, big fair, for example, in some kind of technology fair and so on, be seen there, it's quite expensive. But then to have their country pavilion, your cluster pavilion there, and to be there together with other companies, that then boosts you, and then it's easier to get attention to do their joint events and this kind of thing. And that's what we're doing for our companies.
Okay, but then looking the road ahead and coming back a bit to the mineral exploration, maybe a question to you, Jari, that what is kind of the one investment or policy change that could unlock a major progress for the sector, next to what's already happening with all the strategic projects and so on?
Well, from the European context, I would say that one of the biggest challenges is the lack of funding for exploration. So we have now the EU strategic projects, so basically projects which are ready to be developed as mines or developed as a processing plants or recycling plants. But currently there is not that much funding available for exploration, whether it's for research projects or for actual targets within the European borders. So I think the funding for the exploration, I think this is one of the biggest challenges.
Mm-hmm. Is there something that keeps you up at night? Kind of like a geopolitical risk from the mineral exploration point of view too, or talent shortage, something else to add to this?
Not really. I like to watch or see the world not as short term, 1 year, 1 week, but look at it as a long term pathway. So if we look at this as a long term, we have steps there and there, but eventually we are going forward, hopefully.
Mm-hmm. All right, as we're actually running out of time, and we do a little lightning round in the end for everyone. So each panelist with a final takeaway and a question also. So starting from Hannes, that what is the one action or mindset shift you believe the sector should adopt so it can drive to the next decade? You can take it from, it's mining, but also from your point of view, you're in interdisciplinary fields.
I would say that innovation is something which needs to be in mindset of decision makers. That innovation should be part of the everyday life. So it's not just which is done somewhere out of the MySpace. No. If we need to develop further, then innovation should be very important in very important place.
Mm-hmm. Thank you, Doris.
My mantra have been the collaboration. I'm a great believer of collaboration between competitors, between the sectors, and I think this is something which is essential. Technology sector can't innovate alone anymore. They need the other sectors, the other industries, the ones who also, in some cases, they inspire with their problems and then this part. So the collaboration, I think this is the essential part.
Mm-hmm. Thank you. Ari?
Yeah, if you think about the exploration, I would say that some kind of mindset change that we need raw materials. What is maybe now happening all the time, that people start understanding we need raw materials. There are more acceptance to establishing mines. And that way there comes also more funding to the exploration part. And then that will help and boost also the innovation. But I would say this kind of, now I'm somehow sensing and hoping that the general attitude is little by little changing. And
there's hope.
I'm expecting that. Yeah, let's hope.
All right. And Jari?
Well, actually, second with Doris' comment on the collaboration, I would add also a second layer, which is dialogue, so communications, but also listening. And when we have, as the mineral sector is challenging environment to work, so you have a strong opposition or strong in favor. So I think when we have good dialogue between the different players, I think we can then develop successful projects.
I guess kind of like a summary that innovation in mineral technology is not about digging deeper, it's thinking smarter and so on, right? All right, thanks everyone to the panelists. We give a round of applause. And we do a quick closing also of today's seminar. And I think everyone can agree that we live in an exciting time. So there's so much innovation. It's the most important thing currently in different sectors. There's so much advancements needed as well in Europe, but also globally. So I thank you all, to all the speakers, all the partners, participants for driving the conversation forward. Let's take these ideas beyond this room and into action. Thank you. Please stay for networking also, and thanks all for people online. Have a pleasant evening.